In video games, the camera is probably the most important aspect of every single game. It's the thing that the player interacts with the most and can honestly make or break an experience. However, in the process of game development, the camera is probably the least sought out feature for a developer to work on, and that's for plenty of reasons, but it pretty much gets summed up to it's boring. But that shows itself in the amount of content and tutorials released on the concept of cameras in video games. A lot of them get straight to the point and move on just as quickly, but in most games there isn't a one-size-fits-all solution to your camera, and if there is, you most likely didn't work too hard on it and you should probably get back to that. A lot of the times you're going to need plenty of different kinds of cameras in your video game, and there are a lot of different ways of going about doing this. The most common that I've seen so far is just making a new camera and switching to it, but that's not incredibly scalable on your system and it's usually not a good idea. Today, I'm going to show you a nice, easy, and powerful, flexible solution on how you can go about creating multiple different cameras as well as switching to them when you need them the most using the power of the Finite-State Machine. Most people, when they hear finite state machine, they have one of two reactions. Either they have no idea what it is you're talking about, or they get pretty scared because they equate finite state machines with the concept of artificial intelligence. And though AI is a strong proponent of something that utilizes this system, finite state machines are flexible, powerful, and very lightweight and can be applied to many different things. And they're a lot simpler than you might think. A finite state machine is simply just a data model used to manage sequential data blocks known as states. States can be anything that you want it to, and all they're there for is to manipulate various pieces of data. You can take this concept and apply it to many different things, and one of my favorite ways of applying them is to cameras specifically. As a quick preface before we get into this video, a few things need to be said. I am doing this tutorial in Unity, however, you can apply this concept to literally anything you want. Take Unreal, for example. You could put the FSM inside of the player camera manager and have the same or similar results. I am teaching the concept, not a hard Unity tutorial, and on that note, I won't be going into Unity specific details in this particular video, and I am going about the assumption that you already understand the base concepts of Unity before clicking on this video and going through the rest. Now, with that out of the way, let's get started. Before we get into it, I want to point out that I am using the Unity Starter Assets third-person character controller as a base for this project. You can pick it up on the asset store right now for free. This system uses Cinemachine and the new Unity input system, and if you're using Unity, you should probably get familiar with both of those things in the first place, and this is a great place to start. Now, for our own actual project, we're going to create 3 classes off the bat, and these classes are going to be our state machine, our base state class, and we're going to create a starter camera state as well. I would also like to mention that in this tutorial we're going to be diving into the third person controller class. You don't need in-depth knowledge on it, but it's a very short class, so I would recommend looking over it before we get into this as well. Now we're going to start off in our base state class real quick, and one of the things that I'm going to point out first is that this class isn't actually going to be a mono behavior. We want this class to stand on its own. We're also going to make it an abstract base class as well. If you don't know what an abstract class is, an abstract base class is a class that is never intended to be instantiated directly. We want to override this class with different types, and that makes a state perfect for an abstract base class. Now, the main 3 functions that you're going to need in this particular class are on enter, on update, and on exit, and they do as you could probably guess. On enter is used so we can initiate variables, on update is going to be used so we can update them with blocks of logic, and on exit is going to be used to safely clean them up after the fact. As you may have noticed, all of these functions are virtual because we may want to override any of them and all of them with each new state we create. We don't necessarily need to override all of them all the time, but for the most part, you're probably going to be overriding on enter and on update to do the things that you want for each state. Now, what we're going to do to make the state a little bit more flexible is we're going to add a couple of more variables in here. And these 2 variables that we're going to create is a time variable to keep track of how much time the state has passed, as well as a reference to our state machine. And we're doing that specifically in Unity for a reason, is because since this class isn't a model behavior, we're going to be able to get the components easily, so we need the state machine as a reference. But it's also just good to have a reference to the actual state machine as well, because we want to be able to change the states inside of the states functionality whenever we want, and having a reference to a state machine will make that much easier in the future. And because of that, we're going to override our onEnter function to have another version that takes in a state machine as well. And so this is what we're going to do to set our state machine. Actually, I'm just going to make this the base, because we're never not going to want to have a reference to the state machine in this particular model. So, but if you wanted the option of having it or not, you could just create an overridden function. But for now, I'm going to keep it like this. As well as we're going to start taking time inside of this update function as well. And since we're here on the concept of update, what I'm going to do is I'm going to create 2 more functions that are going to have similar uses to onUpdate, but are slightly different. And these are going to be onFixedUpdate and onLateUpdate. And I'm also going to add in 2 more time variables as well to keep track of how much time an onFixedUpdate and onLateUpdate has been called. I don't know why onLateUpdate happened twice. And the reason why I'm creating these 2 separate onUpdate functions is for a very specific reason. In terms of cameras, you probably always want to update your camera on late update, because when it comes to cameras, having a camera be too responsive can be jarring for the player. And sometimes it makes it feel like the camera's moving before you do what you want. It's custom in video games to have the camera kind of lag behind the player smoothly, and this creates a much more cohesive experience as a whole. So this function on late update is incredibly important. And I added on fixed update here just in case, because sometimes you want functionality to happen specifically on a fixed time step. Last but not least, I'm going to add in some Unity specific code that I'm not going to fully go over. These are called pass-through functions, and these are going to be imperative so we can get our objects and do various things. And with that, we have our fully completed base state class. Now it would be a good time to update and change our base state machine class, and that is exactly what we are going to get started with. The first thing we're going to do is get rid of this start method and also get rid of this, and we're going to create a public reference to our current state. The next thing we're going to do is we're going to create a private reference to our next state. And what we're going to use this variable for is we're going to set this as kind of like a sanity check to change our state, because we don't want to change the current state immediately, because we want to be able to exit it out. And so this next state will cache in the next state that will be passed into the machine so it can move smoothly along its way. The next thing I'm going to do is I'm going to update this onUpdate function so that we can add in our base state functionality in. And this is going to be incredibly simple. All it will do is it'll check to see if next state isn't null, and if it isn't, we're going to create this function in a minute, but we're going to call this function set state, and we're going to pass in our state variable right here, and then we're going to set next state equal to null. As well as, while we're updating, if our current state actually equals something, what we would want to do is we want to iterate through the current state's onUpdate function so that it can call its functionality and update whatever it is that we need to update in our state machine. Next, we're going to create this set state function. It's going to be a private void, and it's going to take in a new state. What this is going to do is it's going to exit our current state if we have one. And so we're going to call current state.onExit here. And regardless of whether or not that current state is active, we're going to set our current state equal to this newly passed in state, as well as start the state life cycle and call its onEnter function and pass in this as the current state machine. Last but not least, we're going to add one final function, and this is going to be a public void set next state, which will set our next state if it is valid. And this is the base functionality for our core FSM. It's a lot simpler than you might have thought. It's just a few lines of code. In this update function, it checks to see if there's a next state to be added to the current loop. And if it is, it'll do its necessary checks, exit the current state, start the new state, and then start iterating through the current state that we have. We have this public function to set the next state cleanly and safely that can be called anything and anywhere that has access to this particular state machine, and it can be passed in anything that has a type of state to it. Last but not least, since we added in those extra update functions, we're also going to add in two new functions to iterate through those late updates and this fixed update, which works similarly to this. Now that we have that out of the way, it's time to actually create our first camera state. However, what we want to do in this particular project as a whole is we want to rip the camera functionality out of the third person controller class, and we want to put it in the camera state. We want our camera to be solely driven by the state machine. And so we don't want any of the things that might manipulate the camera to be in any of the other classes. This is to keep it all clean in one place. And so if you have a camera issue, you know exactly where to look. Now, the third person character controller has a number of variables and one particular function that we want to rip out of this particular class. And that function is this camera rotation function. And as well, actually, there's actually two now that I think about it. There's camera rotation, and there's also this helper function of clamp angle. Camera rotation is used to rotate the camera based on mouse and analog stick input, and clamp angle is a helper function that clamps those values into something usable for rotation. So what I'm going to do now is I'm going to rip these two functions out, and I'm going to put it inside of base camera state. And since we're here, we're going to make sure that our state is a type of state. We're gonna get rid of this since we're here as well. Now, as you can see, there are a lot of variables missing from this particular function. And so we're gonna rip all of those out right now real quickly, and I will do a quick cut to show you what all of them are, and you can move them on your own time. And here are all the variables that you would need to move over from that class to this class to have all the camera functionality be in this base camera state. Out of all these variables, the only ones that are important to us are the cinemachine target, as that's what is used to modify the camera that we're using. And that is because the camera is set up in such a way with cinemachine to always follow this objects attached to the player. The other thing that's going to be helpful for this is this bool lock camera position, which I made into a protected variable because we might want to use this in future camera states. Not all of our camera states want to be manipulated by the camera position of the input that we give it. Sometimes you want the state to fully control where it's looking. And now all that's left to do is to override these functions that we have created for this particular camera. However, we don't want to override the on update function. What we want to override is the on late update function, because again, we want our camera to kind of lag behind the player's movement because it gives a smoother and easier feel to it. And now that we've gotten all of that in, we can start putting functionality into this camera state. And that's as simple as just putting functionality in these functions that we created. And the reason why we're caching this here as on this camera state is because we don't want to have to call this get component all the time. And this is a variable that we're going to be using all throughout all of our particular camera states, because in order for this particular setup to work, we have to manipulate this object in some shape, form, or fashion. Now on to our late update function. It's as simple as calling camera rotation. And on exit is just going to stay as is. We don't need to actually clean up anything in this particular case. Now, before we go back to the editor to try this out, I want to set up a few more things to make our state machine run a little bit easier. I'm going to set up two brand new variables to the state machine just to make this process a little bit quicker. And these are going to be custom name and main state type. Custom name just gives the state machine a custom identifier that I can use for various things. One of which I like to use is to set my main state type. I like having a main state for state machines to default towards so that if nothing else, it will run that one. Unity has a fairly easy way of setting it up with two easy functions in awake and validate, as well as we'll add one final function to tell the state machine to default to that particular state. And this is Unity specific stuff as well, so I'm not going to go into grand detail into how it works, and you can copy it right now. Now with that out of the way, we can go back to Unity and we can set it up. Back into our Unity project, after we read and compile our stuff, what we can do is we can get access to our player armature over here, and I am going to add in a state machine, and I'm going to give it the simple name of camera. Now, if we run the actual project, it should, in theory, work the exact same way as it did before, but now it is powered by our state machine. And with this out of the way, we can actually add some very custom and nice camera states to our overall system. And that's what we'll just do now. Now I'm going to show you a quick and easy example on how you might utilize this system in place by implementing a very incredibly simple camera target system in our setup example project. Camera target system is as simply as follows. If there's an enemy target, we'll look at the target and follow it, much like a lock-on camera system would in a normal game. Now, as an aside, this is going to be an incredibly simple, bare bones way of doing it, and I don't actually recommend doing a system like this. However, the camera state is going to be in a way that is incredibly easy to use and implement in your own kind of system. Now, I have a few things set up in place to make this a little bit easier to teach. I created this custom prefab, and if you're wondering what this is the exact same thing as the player armature prefab. It just doesn't have any of the input classes attached to it. And of course, I called it enemy armature. Also, it has this particular class called enemy script to it. This is nothing complex. All this does is it holds a reference to the camera root that is attached to this enemy. And in most cases, you would already have an enemy class for your particular game or project. So you would just add a reference to the camera root to there. I will show the functionality for all these imported classes onto the screen for you to copy. Now, the second thing that we're going to have to add to our particular player armature is going to be this detection sphere. And I'm going to make this sphere 5. It's just big enough to encapsulate our brand new enemy, which I'm going to move a little bit forward and rotate around real quick just so he can face you as your challenger. And with that out of the way, the last thing that we're going to have to add in is a new C# script. And this is going to be our combat camera state. And this is going to hold the functionality for that particular camera lock in it. Now, before we actually get to our camera lock functionality, there are a couple of things that we're going to have to modify for this system to work nicely. And that starter thing is going to be the player input. We don't actually have an input for the targeting functionality, so we're just going to add in a quick new input right now. As well as we're going to have to access the starter assets input class, and what we're going to do is incredibly simple and bare bones. Back into Visual Studio and the starter asset input, we're going to essentially just copy the functionality of Sprint, but we're just going to make it for our target. So we're going to create all the same we're going to create the two functions and the variable that already exist for this particular Sprint functionality, and we're going to lock it in. Last but not least, we're going to have to modify our third-person controller class. And again, this isn't an intensive study on how to go about creating a targeting system in Unity. This is about the camera controller. So I'm just going to briefly explain what we're going to have to be doing, and I'm going to show you code snippets so you can add it in at the right spot before quickly moving on. Our targeting system is going to be incredibly simple and bare bones. We're going to hold this dictionary of targets that will be added and subtracted to via our detection sphere, which will add targets in the dictionary if we're within range and remove them if we're not. The most important function out of all this is going to be the choose target function, which is essentially just takes the closest target to our player and sets it to the current target. If we find a target, we'll set our state machine to start playing the combat camera state, as well as if we hit the button again and we are already in that state, it will end that state and set us back to our main state. But not going to spend too much time on this. We're going to move on to our base camera state class, because this is what's important. First things first is we want to derive this camera state to be a camera state. And that's the power of abstraction, by the way, if you haven't already figured that out. And in order to create this follow target, it's incredibly simple. A lot of our base functionality is going to live inside this camera state, and because of the nature of that, it means our more complicated camera states can be a lot more simple and have a lot less fat to it. First things first that I'm going to do is I'm going to create a starter assets reference to our controller class, because we need this class because of the system that we created. This controller holds the reference to our current target. And then the next thing is as simple as follow. We're going to create our 3 classes once again. And in order to do this, we're just going to create a simple lookat for our Cinemachine target. Now, if we go back into the Unity project and we run our game, the camera should act normally like it did before. You have your various axes of rotation that you could do with your controller or your mouse. But if you hit the right trigger or tab button, there you go. You have a simple camera lock onto the enemy in front of you. If you hit it again, it moves back easily to the main camera state that we created back at the start. And that is the power of the camera state machine. You can utilize this to make plenty of camera states you want and smoothly and easily traverse through all of them as quickly as possible. And it's as simple as creating a new combat camera state. That's going to be the end of the video. And did you know there are around 33 species of seals? Yeah, there's a lot of them. I don't know why.